Hey guys, welcome back. So this is the first official notes of our trig unit. And today we're going to be talking about angles and angle measures. So the first thing, an angle is said to be in standard position if the vertex is at the origin. So when we're talking about angles, we're going to put them instead of as a shape like you did in geometry, we're going to look at them as on a coordinate plane. Okay. So here's our coordinate plane. The vertex, which is like the point of our angle, is at the origin. So that's the first step. The second one is that the initial side is on the positive x-axis. So if this is our vertex, then the initial side is on the positive x-axis. So this is the positive x-axis. This is called our initial side. And then how we need another ray to make an angle. So wherever our other ray is, this is called our terminal side. And this is where our angle ends. So this would be our angle. And a lot of times we denote the angle with the Greek letter theta, which is like a 0 with a line through it. A counterclockwise rotation represents a positive angle. So if I'm measuring my angle in a counterclockwise, this would be a positive angle measure. And if I measure it in a clockwise rotation, this represents a negative angle. So depending on how you measure it, if I measured it this way, this would be a clockwise motion. This would be a negative angle. So even though they make the same kind of shape, how we measure it, which part of the angle we're measuring, determines if it's positive or negative. And we have two different units that we measure them in. So the amount of rotation is measured in either degrees, which are what a lot of you guys are familiar with, or radians. And you may have learned this in geometry. You may have learned it and you forgot it, and maybe you didn't learn it at all. Who knows? But we're going to talk more about radians later in the notes today. So example 1, we are going to draw an angle with the given measure in standard position. So A, 215 degrees. So remember, if we're talking about standard position on our coordinate axes, where our vertex is at the origin and our initial side is on the positive x-axis. So now let's think about this. We're not going to get out protractors and measure. I'm basically just looking to make sure you're in the correct quadrant. So if my angle didn't go anywhere, if it started and ended here where my initial, this would be at 0 degrees. Now, if I went straight up and down, if I went straight up to the positive y-axis, this would be 90 degrees if I measured my angle there. If I measured it all the way to the negative x-axis, so like half a circle, this would be 180 degrees. If I go past 180 and go straight down, this would be 270 degrees. And then if I go all the way around, it's the same angle or same line as 0 degrees, but if I'm going all the way around, it's now 360 degrees. So now for A, if I'm looking at 215 degrees, 215 degrees is between 180 and 270. So it needs to be between these, and it doesn't have to be exact, guys. I'm checking to see if you're in the right quadrant. So 215 is between 180 and 270. That's where we draw the line. And then we need to denote which part of the angle we're measuring. So since it's positive, we're going in a counterclockwise. So this would be our angle, 215 degrees. B, negative 40. So let's make our coordinate plane. where our vertex is at the origin, and then we're at the positive x-axis. So now if I'm talking about negative 40, negative, rotate in a clockwise position. So remember, if I didn't go anywhere, this would be 0. And now because it's negative, I'm going in a clockwise motion. So instead of going up, I'm going to go down. So when I go straight down, this would be negative 90 degrees. If I go straight down and then to the left, this would be negative 180 degrees. If I go past negative 180 and then go up, I'm at negative 270 degrees. And if I make a full rotation in a clockwise motion, I'm at negative 360 degrees. So then I think negative 40 is between 0 and negative 90, so it's got to be here. And it's this angle right here, negative 40 degrees. All right, so what I'd like you to do is try C and D for me. See if you can get those. So go ahead, pause the video right now, and then when you come back, I'll show you the answers. All right, so go ahead and check your answers, see if you got them correct. And again, I'll be available on Remind and during office hours if you have any questions about any of these as well. All right, so our next part, coterminal angles. So a coterminal angle, co means the same, and then terminal, we're talking about our terminal sides. So what this means is that they are angles that share a terminal side. So for example, if I look at my past graphs, you don't have to actually mark this, but if you see 0 degrees and 360 degrees, they are on the same line. Also with negative 360 degrees, these are all coterminal angles. If I look at 90 degrees and negative 270 degrees, these are also coterminal angles. And then 180 and negative 180, again, these are in the same position. They are also coterminal angles. So one way that we can find them, so to find these angles, you're basically ending up in the same rotation or the same direction that you started. And to do this, you're going to add or subtract 360 degrees, or any iteration of 360 degrees. So I can keep adding 360 degrees and end up in the same spot. So if you think about like turning in a circle, when you like turn in a circle, if you turn 360 degrees, you're facing the same direction. So if I turn another 360, so that'd be what, 720? So then you're still in the same direction. And then if you did another 360, would be 1080, and then another 360, 1440, and etc. And you can also subtract. So remember, when you subtract and you get a negative angle, that just is you're rotating in a clockwise motion. So, example 2, we are going to find an angle with a positive measure and an angle with a negative measure that are coterminal. So basically, we're going to take whatever angle we have, we're going to add until we have a positive coterminal angle, add 360. We're going to subtract 360 till we have a negative coterminal angle. And sometimes you might have to subtract multiple times. So A, we're looking at 130 degrees. So to find a angle with a positive measure, so a positive degree, we're going to take 130 degrees and add 360 degrees, which would give us 490 degrees. And if I need a negative, I can subtract 360 degrees, which would give me negative 230 degrees. All right, let's try another one. So I've got negative 200 degrees. Here I can add 360 degrees. Negative 200 plus 360 is 160 degrees. And then negative 200 degrees minus 360 is negative 560 degrees. All right. So I'd like you to try C and D. So pause the video and try these on your own, and then when you come back, you'll be able to check your answers. All right, so go ahead and check your answers. That's the end, page 1, so page 2. So radian measure. So what we just did everything was in degrees. So radian measure. So a radian, if degrees, that's generally how we think about it when we're measuring angles in degrees. What a radian does is it puts it in terms of a circle. So I actually don't like that circle at all. What I'm going to do is I'm going to make a coordinate plane. It's a little bit better. So what a radian is. So a circle from the center to any point on the outside, this is your radius, your R value. So imagine we measured this with a piece of string, and I would have you do this in class if I could, but and then what we're going to do is we're going to take this same measure, this R, and we're going to take that string and bend it around the circle so that these are the same length. And then wherever that ends, that piece right there, this angle that it makes is 1 radian. So say we had a radius of 3, and then we measured this arc length to be 3. Then this angle that would be formed would be 1 radian. So how we find arc length. So now what we're going to try and do is find some kind of conversion rate between radians and degrees. So your formula for your arc length, we say this is S equals R times theta. So where S is your arc length, your R is your radius, and your theta is your angle. And it's important to denote that your angle measure is in radians. Okay, not in degrees. So if we think about your whole circle. So if we think about a complete circle, all the way around is called your circumference. So if I go all the way around the circle, the distance is your circumference. And your circumference measurement is 2 pi r. So this should equal our arc length, which is r times theta. So if I divide each side by r, I'll get 2 pi equals theta, which means that 2 pi radians is the same thing as a complete circle, which is 360 degrees. Okay, so 2 pi. So that means if I took this r value here, I could make 1, 2, 3, 4, 5, 6, and this little extra, okay, which would happen to be about 6.28, which would be 2 pi. So if you tried to fit pieces in there. The important part of all of that is coming up with our formulas. So if we know that 2 pi radians equals 360 degrees, divide each side by 2, this means pi radians equals 180 degrees. So when we're trying to convert from degrees to radians, we are going to multiply by pi divided by 180 degrees. And if I'm going from radians to degrees, I'm just going to do the opposite, or the inverse. I'm going to multiply by 180 degrees over pi. All right, so 3, rewrite the degree measures in radians and radians in degrees. One way to tell, degrees will have a degree symbol generally. Radians will generally have a pi somewhere in there. So A, we're going to take negative 30 degrees, and we're going to try and put it into radians. So from degrees to radians, we're going to multiply by pi over 180. So I'm going to multiply by pi over 180 degrees. And our degree symbols cancel out because we have one on the top and one on the bottom. So I'll get negative 30 pi over 180, which I can reduce to negative pi over 6. B, I've got 5 pi over 2. And again, no degree symbols, which means it's in radians. Also a key is that has a pi with it. So to go from radians to degrees, we're going to multiply by 180 degrees over pi. So here our pi's cancel out. 5 times 180 degrees would be 900 degrees over 2. And this will actually divide or reduce nicely. So this is 450 degrees. Let's go ahead and pause the video. And you're going to try C and D. So go ahead and check your answer. For C, you should get 2 pi over 3. And for D, notice it doesn't reduce nicely, so we leave it as a fraction. D will reduce nicely or divide nicely into a nice decimal, negative 67.5. It's an ugly decimal, so it's repeating, or it doesn't end. Make sure you write it as a fraction. All right, so find an angle with a positive measure and an angle with a negative measure that are coterminal with each. Okay, so we did coterminal already. Remember, it has the same terminal side, so it started and ended in the same spot. And what we did is we added and subtracted 360. But now we're given these measures in radians. And if we remember, in our radians, 2 pi was the same thing as 360. So I'm going to go back and update my coterminal from the previous page. So to find, you're going to add or subtract 360 degrees, or add and subtract 2 pi. All right, so example 4, find the angle with a positive measure and angle with a negative measure that are coterminal. So for A, we're going to add 2 pi and subtract 2 pi. So I've got pi over 4, and first I'll add 2 pi. Remember, when we're adding these fractions, we need common denominators. So I need to make this this 2 pi have a denominator of 4. So I need to multiply this by 4 over 4. So that when I get this, I have pi over 4 plus 8 pi over 4, which gives me 9 pi over 4. So there's a positive one. To get the negative one, I'm going to subtract 2 pi. So I'll have pi over 4 minus 2 pi. Remember, we need common denominator, so I need to multiply this by 4 over 4. So I get pi over 4 minus 8 pi over 4. 1 pi over 4 minus 8 pi over 4 gives me negative 7 pi over 4. And there's my two answers. So I'd like you to pause the video and try B. So pause the video and find coterminal angles for negative 2 pi over 3. Go ahead and check your answers. You should get 4 pi over 3 and negative 8 pi over 3. Now, these are the end of the notes problems, but there is one thing I need to remind you guys of. Students generally forget how to do this, but when we talk about the quadrants, so on your homework it asks which quadrants are these angles in. Quadrant 1 is the top right, quadrant 2 is the top left, quadrant 3 is where they're both negative, x and y are negative, bottom left, and quadrant 4 is the bottom right. All right. So if you have any questions, feel free to send me a remind or give me a chatter, and I'll talk to you guys later.